Okay, next is our own Steve.
Hi. So I have a bit of an update here on my mock TurtleBot.
Did you call it a mock TurtleBot?
Yeah, it's a mock TurtleBot because it's a iRobot Create in terms of like what the current TurtleBot has. I have an iRobot Create base, I have some standoffs, I have a Lucite deck, I have basically everything except for the Kinect. I even have like a gyro board now, and I've been kind of missing a battery.
It went way up underneath it.
Yeah,
The other one, the 7-Up one. There.
Yeah.
Oh crap!
Not to worry. Straight as it's. Yeah, Steve Robot too. Yeah.
True Robotics is 3 batteries.
Yeah. So yeah, just need one because the other one's cool. Thank you. So so I found myself actually building a lot more than I had initially thought. If you're not, turns out if you're not kind of taking the whole kit, you pretty much have to build everything yourself. One thing I found that people are doing when they're hacking the XV11, they're usually using the LiDAR integrated into the XV11, so they're just talking to the system board. Since mine is external, I've had to work with the firmware on the LiDAR unit itself, which it turns out is a later firmware revision than most of the other software out there. Is like the Rosnode expects 2.1 firmware, LDS 2.1 firmware. There's some other code that people have written that's using 2.4. It happens to be using 2.6. So the bytes in the ranging data, the bytes in the ranging data packets are kind of flipped around. So I had to figure that out. I figured that out last month. The other thing is that that's controlled by the Neo main board is the LiDAR only works and gives you valid data if it's spinning in a very narrow range. So it's like 300 RPM. And there is a data packet that in the ranging data that you get that tells you how fast the motor is spinning. So I built myself a little PWM circuit here, hooked up to an Arduino. Hooked up to an Arduino that reads the data coming off the LiDAR, and my accomplishment here has been getting the LiDAR. So this board right here is actually reading the RPM bytes coming out of the range data and is PWMing the motor to keep it within spec. So that was a bit of an interesting project. Replace the Beagle Bone. Yeah, that was actually that actually involved learning a lot more about electronics than I previously learned. So let's see what else. Making my own little, starting to make my own little adapter board for the Boss controller board. And just mostly stuff is soldered into place and put into place. It doesn't actually work now. That's coming. But yeah, the big accomplishment has been getting the LiDAR usable and independent and running by itself. So the cool thing is that this will run, I can get data off of this independent of having it hooked up to anything else. I don't have to have it hooked up to the laptop anymore or anything like that. And then hopefully, like maybe in the next month or two, we'll actually like make use of the data coming off of here and move and make some navigation decisions and actually be a functioning mobile robot. So that's pretty much about it. And there's the code for all of this is up on my GitHub. So if you're a Pythonista and you're interested in what sort of a latter-day LDS looks like, please take a look at my GitHub on Chat Hello. Cool, thank you.
Testing.
Patrick, do you want a pylon?
You got one? All right. Pile it on. So what I'm going to demonstrate here is actually something I never thought I would be doing, which is teleoperating PyRobot, because the whole idea behind my little project was to work on autonomous behavior. But as some of you know, I have a person at work who's is disabled and has to be basically confined to a reclining position about 90% of the day. So she thought it'd be pretty cool if we could figure out how to get her to teleoperate PyRobot around the premises. And basically what I'm going to demonstrate here, hopefully you can see it on the screen a little bit. This is an HTML5 JavaScript interface to ROS, using the ROS bridge package to send the packets back and forth between any HTML5 compatible browser, which is basically Chrome is all I use. So just for the fun of it, if anybody in here has their laptop on, anybody, like everybody, right? Or their tablet, look for a router called Pi_robot. It's open. Go ahead, connect to it. And when someone gets connected to it, I'll give you the IP address to type in, and you'll actually be able to remote control PyRobot from anywhere in this room. Okay, so it's got a router on it, which is Dave Curtis's idea, which is just proving to be fantastic wherever it is.
Dave Curtis.
Dave Curtis, all right. So we're not using the infrastructure Wi-Fi here at all.
So
Oh, you got PyRobot?
Yeah, I got PyRobot.
So go to 192.168. No, just type we'll bring up Chrome, Google Chrome, or any HTML5 browser. Anyway, so PyRobot has a camera, of course. It happens to be an ASUS depth camera. I put a wide-angle webcam down here. This is more useful for indoor use. So you can actually toggle between different video streams with the UI. It has a Koyu laser scanner at the bottom, and that's for telling you when you're about to run into things, because of course cameras tend to have a fairly narrow field of view, both left, right, and up and down, so you don't tend to see what you're about to run into unless you constantly tilt the camera down. And hey, did you just steal my video stream? There we go. So you can manually tilt using the left-hand trackpad. The screen one over here. You can certainly look around with this camera as you're moving about. And then with the right-hand trackpad, using your right thumb on a tablet, you can move the robot around. Are you doing it?
So
Like go around a pylon. I'm not sure. So the idea here, though, is I won't be looking at the robot. So I have to turn around. And then we're going to put the camera slightly down so I can see the pylon and the floor. There must be one hell of a lot of wireless noise in here.
Imagine that.
Oh, is somebody tilting my head? That's supposed to be pointing down. I shouldn't have given away the address. All right, someone's really messing with me now. Who's doing it? Yes. All right, someone's really messing. Well, I'm just going to try driving it. All right, we've got 16 people controlling it right now. So we'll just go. One thing I have tried to do is combine a little semi-autonomous behavior with the teleoperation behavior. And that's to say, for example, the laser scanner will automatically stop you from going forward if you come within about 4 feet of an object. And I have 2 ping sonar sensors, one oriented in the front, one oriented toward the back, so you actually can't back up into something as well. You can try, but it'll stop you. What else?
Nice.
So who else is controlling it? Are you controlling it, Steve?
No, actually this one doesn't. Oh, I'm pushing buttons, so I don't know if that's what you
Oh, okay. So if everyone will leave me video control, I will try one round without looking. I do have the disabled woman at work actually navigating around the premises, and today she had a pretty good run around a couple of posts that were very good practice for. So here we go. I see the green pylon. I see the pink pylon. The laser scanner tells me that the green pylon is to my left. There's a little red dot that tells me that. I see some feet kicking around on a chair. And there's a hand. Hello. And where's the green pylon? Below. And there I am. Uh-oh, very close, very close. I'm right. Ah! Uh-oh. Is somebody going backwards? Someone's going backwards on me.
There are several people here who don't.
Okay, here we go. That looks like a familiar backpack. There we go. All right. Thank you.
Watch your step, watch your step.
Hello. There we go. My name is Justin Eskison. I do apologize. This is not a functioning robot yet. This only got assembled this past weekend. I intend for this to be a Robo Magellan entry for this next coming year. And so what this is a basically an office in the 6-wheel base, and then it comes with an Arduino-based motor controller. Under here, I have a 10 amp hour battery underneath, and on the top I have bolted a Panda board. I have an APM2 board from DIY Drones. I don't know if anyone is familiar with those, but it gives you full IMU, the accelerometers, the compass, and the GPS, and all the stuff that you would need for navigation. It's sort of meant to go into a aerial vehicle by itself. And I have a PlayStation Eye cable tied on the front for computer vision. So that's about it. Yes.
Why are the wheels canted in so far?
It has basically it can take a lot of weight. It just
Suspension?
yeah.
Oh, I see.
Probably.
Weighing it down, it evens out.
Yeah.
Okay.
So basically, it's
Unloaded.
Yeah, it's unloaded, and you can adjust the suspension on that. And I probably should make it a little looser. I haven't really gotten it to the point of running. The minimum setting on it that I can spin the motors with is really fast, and I haven't gotten it with the past couple of nights being rainy like it is. I haven't gotten outside yet with it, so it's too fast for indoor at the moment.
It's nice, it's great. Looking forward to seeing run. We have show and tell every month, so bring your robots. Hello, John, how you doing? Nice to see you. John's a long time, maybe here like 15 years ago.
Well, this is my latest project. It's not actually working today. It was working, but I've been taking it apart to add some more intelligence to it. What it has basically is a remote control unit, and it's mostly made out of tape, because I don't have a lot of time. So the miracle here is like metal tape. If you can get metal tape, it's awesome. You can make like things that are really strong and they stay together. This one I originally made just to kind of cruise around out at the beach, drive around, and explore the underworld habitat of wild animals in the brush. So it actually is pretty good. It doesn't get hung up too much. And I'm just it uses a remote control, and I'm right in the middle of building in kind of a remote control override so I can put it on a robot drive sort of idea. Anyway, it has a little camera on it, runs, and I'm sorry it's not working today, but I totally promise to bring it when it is.
We appreciate you bringing it.
Yeah, just wanted to share.
All right. John and John, actually we got Alex first. All right, come on.
You said you wanted to do it.
That's fine, come on. We're trying to do this other thing, but it's cool. Got a lot of robots, it's great. Hey, wow, look at this. Alex and Andrew, right? Yes. Yeah. Which is which? I don't know.
I'm Alex.
So I've been working with this robot off and on.
Quiet down the erector set over here.
I've been working on this off and on, but it's really more for trying to test out different ideas. So it basically has it has a microcontroller at the bottom for the for motion, and that includes dead reckoning. The bad part is that the UI isn't that great, so I'm looking at some people who can help me improve the UI. So it gives me the current position of the robot in terms of XY in the room or wherever it's located, and allows me to specify where to go. One thing though is that somebody moved it, so it's now lost. So I have to do in a sense, a manual operation. So right now, giving it commands is basically a text-based, which is not the greatest. The other part that it has is an arm, and the arm is so basically you can raise and lower the arm and use the arm to reach onto something like a can or some other object. I can probably do more demo later offline because it takes too long to do anything.
What are those pinchers made of? What are the pinchers made of?
Oh, okay. The pincer itself is well, it's homemade, but it basically is able to grab an object up to 3 inch, and it has force feedback. This round thing is actually a force sensitive resistor, so you can actually apply a controlled force that you can specify how much you want to squeeze. So the idea is that if you're holding something heavy, it holds it tighter, and if you're holding something soft like a paper box, it will not crush it. The other thing is it has a camera set up that is basically decoded in software, so you can actually see some of the image processing that's being handled. The camera is going to be used to basically identify an object on the table, locate the distance, and then allow this one to capture the object. There is feedback also, an optical feedback that measures where the object is on the table. The other part of the work here is to figure out, to do all the what they call inverse kinematics onto a processor in here instead of letting the host do it. So the idea is that to start offloading some of the processing from the host so that we can use the host for more higher level processing. I can do one function on the arm just so that so basically I position 5" by 5" 5" height over this reference. And for example, if you need to grip something, if somebody wants to put their hand here, you can actually feel the force that's used to say. In here. So you want a strong one or a weak one? Probably not. I don't want to get into trouble. Exactly. We'll do a weak one.
Pretend it's a piece of paper.
I mean, it's slow, but you can feel that it's not very, very strong, right? It's sort of gripping you lightly. So if I can slightly increase it, yeah, you feel it? It's a little stronger. Yeah. Okay.
Say when.
Oh, okay.
It's not letting you go. You're stuck there.
Hey, you can take it out.
Okay. This is my Magellan robot. Going to be Magellan robot. It's an update. So before I had like literally nothing working. Now I have the compass working, the motor's working, and the servo's working for the steering. But the GPS is not working because I ended up buying GPS, which is really hard to use.
The cheap one.
The cheap one. Yeah.
How's that money saving going for you?
Not very good. I can show how the motors. I just written the program, so I don't know if it's gonna work. It might work. Okay.
It worked a little while ago. Hey!
Whoa. Well, it's not working. Yeah, but what it's supposed to do, it's supposed to spin up the motors from 0 to full speed and then back to 0. That didn't work, so whatever, at least one speed works for now. I had them working before.
All right. So last month, last challenge, we had a performance piece from myself and John Erickson and John Carlini.
Yes, thank you.
And we want to thank you. Catalina, stand back.
Oh, okay.
It's time for the rock and roll robots. Kids, don't get too close, please. All right.
What is made out of Lego?
Now you tell me. All right. Bear with me, bear with me. It'll be well worth it. This is going to be awesome. You can feel the tension mounting. Hey, we have Stan Howell. Stan Howell here is a long-time member. I was going to say old member, but a long-time member from back in the day. Stan's like the Teddy Ruxpin Hall of Fame. He has a website that specializes in old-timey animatronics, right? Stan Howell, ladies and gentlemen. Welcome back. In town from Las Vegas or somewhere. All right, here we go. He came especially for the HBRC Challenge. Okay. Cool. Yeah. Oh, this is going to be totally worth it, I guarantee. You've never seen anything like this before. Nor will you ever again, hopefully. Are we on? Are we on? Okay. Okay. Yeah, safety first, kid. If the robot comes to launch, you get out of the way. Okay. Oops. Okay. Oh, wait. I almost forgot a very important member of the band here. The crow. Poor crow, ladies and gentlemen. Yeah. Carlini over here is talking about our last performance. Okay. We're professionals after all.
Yeah, we're not professional at all.
Yeah. All right. Stand back. This is like holiday appropriate here.
Is they only going to come back around? Or do you want to come back?
That's the monster mash there. Oh, can somebody mic the audio on the computer there?
Where's the mic? You can do that. You're the computer guy.
Go ahead, Carlene. You take the lead there. You see the speakers? Jagger. All right, thank you very much. The Robo Monsters. Okay. Well, we're going to have to recover from that, huh? All right, all right.
I'd like to thank our performances here and for everybody that brought all our robots.
Wait, there's more.
There's more.
There's more. We haven't even done the FloorBot challenge yet. What time is it here? We got time? Look at that. Hang on a second. All right, hang on. We're going to clean up this mess here. Wow, that was really something, huh? I don't know what that was, but it was something. All right, who else has a robot to show? Surely there's more robots out there. I'm sorry, what's your name again?
What I am doing perfectly.
You need a table? We got tables. We got a table for Garrett?
So that way you
Garrett? Was that fun? I told you to All right. Good deal. Oh man, that was awesome. That was awesome. Really fun. Here.
So, I showed it already, but yeah, there are all those emails. I thought I will pull it out and show it again. So this is a micro mouse robot that won a silver medal last year at Robo Games. This year I did not compete because guys from Taiwan came in and it's just not possible. But I repurposed it to do some elements of TableBot. So it is supposed to bring me back this block. Let's see. I haven't been running for a while, so I don't really know what to be doing, but I think it's still old code. Maybe the batteries are ready. But basically what it's supposed to be doing is it has 3 infrared sensors here and it's looking with one of them and detects a block. And successfully detects a block, but yeah, doesn't really go any further than that. A bit further, okay. So, I guess that's it for today. Thank you.
Do we have any more robots besides Camp's FloorBot? This is the going once, going times. You're it.
All right, tag on it. Okay, so we finish it up. So all right, so this is at the end of the another challenge series, our 10th even. I think the year really, I'm good with this. I think the year really is like the apex is the Robo Games. I think that's the the big thing that people gear up for. So Robo Games is in April. Like a week or two before that, we have the Stanford Robot Block Party. Then there's Maker Faire, which Robo Games is really the best part of Maker Faire. So, but but for those, it's the HBRC Challenge. It's a fantastic place to come and show what you've built. I got one more. Actually, I have two more, but I'll hold off on local though. I got some configuration to do on the IP address, but regardless. So the robot inside here is named Scaffold, and this is an experiment machine intelligence book I picked up in 1984, How to Build Your Own Self-Programming Robot by David Heisman, where he describes how to build an 8085 microprocessor control device from scratch. I've spent about 5 years trying to build this 12-bit address bus, 8-bit data bus machine that you load one byte at a time in binary. Eventually, I applied this alpha-level machine intelligence to a store-bought IBM PC with a Relay I/O card, and still trying to program in the beta and the gamma level. So basically, this is where I am. The robot does random motions to try and thank you. The robot does random motions to try and learn back and forth. In alpha, when you have a differential drive, there's 9 possible motion codes, including stationary. And so in alpha, it basically does random patterns until it learns the only motion pattern with any displacement, which is forward or reverse. And I'm going to restart it. Actually, it did get into a nice sequence there. The beta, when it achieves a successful response for a given motion pattern, it retains that memory the next time it's in that motion code and encounters a stall condition. It goes to its memorized response. The gamma model generalizes, and when it encounters a stall condition in a motion pattern that it doesn't have a memory of a direct response, it generalizes other successful beta responses and chooses one of those. So ideally, you'll see the robot learn back and forth faster and faster. And actually, I think I've got him in an oscillating pattern here. So this is kind of a nice way to close the meeting. Thank you very much. Thank you everybody for participating. Thank you for everybody that came out. And looking forward to the next 10 years. Thank you very much.
So with that, I'd just like to thank everybody for coming. And we're going to go into our random access mode. And hopefully we'll see you all the next November, in a month. Okay? Thank you very much.